So with that being said, let's get into the first problem I selected. So
let's do it. All right. Now, just to give you guys a quick caveat. So Laura sent these to me earlier. My original plan was not to look at them whatsoever because I like to do it completely fresh. But I did look at it because I was like uploading. I was like, let me just take a glance. So I've looked at it. But what we have not done is we've not talked about how we're going to solve these to each other. All right. So this is a free response question. So that always adds a tinge of difficulty. We got to be absolutely certain that we've read everything carefully, because I always say the multiple choice answers are like guiding posts, right? They're going to help us decipher whether or not we're on the right path or we've totally missed the mark if nothing pops up. Here we don't even have that. So we got to be extra careful. All right. First things first. We're talking about a triangle. We're talking about a shape. Have to do a diagram. I say you got to draw a diagram no matter how simple the problem is, just because I want that to be in every student's mind as a habit. Do you agree?
Yeah.
Okay.
I agree with that.
All right. So we're going to go in the mix, and we got an equilateral triangle. So hopefully you guys know that vocabulary. It just means all the sides are equal. Now, they give this value. Already, I can see one possible mistake if you're reading too quickly. And this is why for free response, you got to slow down. I could easily see somebody being like, oh, cool.
Yes.
You've had this, you see this? So, right, somebody can say, cool, all the sides are 624, and let me get and then you're host. Now you've built in a false fact into the diagram and everything's gonna be off. Okay, so we say, no, it's not 624, that's the perimeter, right? So since there's 3 sides and they're all equal, we'll do a little division. I think that's 208, right? So now we've got a nice diagram, and it's asking about this K value, which is related to the height. So when you're talking about a height, you're dropping a vertical line straight down from one of the vertices to the opposite side, okay?
That looks so pretty.
I know, I take pride in these diagrams. And then also, you drop an altitude for an equilateral triangle. It's not only going to be perpendicular, it's also going to bisect this other side. So
Yeah.
we're going to roll with that assumption, and this is bisected into 104 like this. And now we've got a right triangle, and we can solve for the missing leg. So I am seeing this, and I'm like, all right, wait a minute. Equilateral triangle, all the angles are also equal, meaning all the angles are 60 degrees, right? When I'm dropping this down the middle, I'm bisecting this. I'm also bisecting this angle, which means we now have a special right triangle, 30, 60, 90. And when we have a 30, 60, 90, the little side is key, because if I know the little side, I know the hypotenuse is going to be double, and I know the long leg is going to be the little side times rad 3. And now when we look back, they say the height is this. I've just now said the height is this. We can match up K with that front coefficient, and K is 104.
Yeah. Love it.
So that's the general way. Okay, now I'll turn it over to you.
I love that way because that's the way you want to do it. They're testing special right triangles, and like 30, 60, 90 is huge, knowing the ratios of the sides. Here's just something that I noticed. This is a cheat code.
Oh, let me see.
I've seen quite a few problems now where literally they just change the numbers and then they ask for the value of K. And every single time you have a problem like this, if you just take the perimeter and divide it by 6, you get your answer. Because essentially, because of the way the ratios work, when you divide it by 3, you get the side length, one side, and then you cut that in half.
Yeah.
And that always ends up being the answer.
Whoa.
So I know. So
Cool pattern.
yeah, it is a cool pattern. I mean, there's some danger in following patterns, right? Because the SAT is smart and they'll throw curveballs and then they'll change up questions.